Look at this second example. We gotta do it with the trig in there, huh? It's not. It's with the trig. Okay. So what does this look like? Well, this is saying, what's the area under this function, this weird looking function? I wouldn't even know what the graph looks like until I graphed it in a calculator or something. But what does this look like here? What is it? Well. First, you must get antiderivative and draw a whale. You don't have to draw a whale. Okay, so let's see. That's a bad whale. So look, it's green. He's sick. That's what that is. It's coming out green. That's not good. All right. So what is antiderivative here? So I can split up the integral and take the antiderivative of that and the antiderivative of that. So what is the antiderivative for cosine? Well, the derivative of sine is cosine. So the antiderivative of cosine is sine of x. And then I can say the minus 3. And the derivative of cosine equals negative sine. So I have to actually say this is plus cosine x, right? Because if I take the derivative of cosine, I get the negative. So there we go. And this is evaluated from 0 to pi. 0 to pi. Okay. Well, what is that? That is sine of pi. Right? You plug in the top one first. Plus 3 cosine of pi. And so many people are going to mess up on this, but I'm subtracting. I must put it in parentheses because there's more than one thing. Okay, so that's sine of 0 plus 3 cosine of 0. So we got to evaluate that. And that, well, sine of pi, just from the unit circle in my brain, sine of pi is 0. Cosine of pi is negative 1, so that's plus a negative 3, right? Because negative 1 times 3 is negative 3. Minus, parentheses, sine of 0 is 0. Plus cosine of 0 is 1, so it's plus 3 times 1. And what do we get? We got to distribute that negative. Oh, some people would have got that wrong, huh? So it's negative 3 minus 3, that's negative 6. So the area underneath that is negative 6. Now, some people are thinking, why don't you put the plus c? What's up with that? Let's take a look. If I did the plus c with the antiderivative, right? I have a plus c there. That means this would be plus c, right? And then on the inside of the parentheses, another plus c, and I distribute that negative, and the c's would cancel out, right? So you don't really need the plus c if you have a definite integral. You can just ignore it because they cancel out, right? So it's the same constant, so that's going to cancel out when you subtract them. So that's why you don't have the plus c. Let's move on, carry on to example 3. My wayward son. I don't have any children. Thank you, Jesus. No, come on, that's crazy, isn't it? No, it's easy. What is this? Well, I can split up the integral between the two functions. So I have the integral from 1 to 3 of 2 dx. Remember, that's the area underneath y equals 2. Don't forget that. And then I have the integral from 1 to 3 of the absolute value of x minus 1 dx. So that's the same thing. So we can do this by using antiderivatives, except for absolute value is a little weird with the antiderivatives. When you do the absolute value antiderivatives, it's kind of like conceptual. So we'll think about that when we get there. So let's think of this. So if we have the integral from 1 to 3, that's a distance of 2, and a height of 2, that would be an area of 4. Let's see if we get that using antiderivatives, like the second part of the fundamental theorem of calculus. So if I do the antiderivative, take the antiderivative, that would be x, or 2x, evaluated from 1 to 3, and that equals 2 times 3 minus 2 times 1, which is 6 minus 2 equals 4. That's what I said. And I need that plus Massa. Okay. Massa. Okay. What do we have here? The area underneath this. If you can't graph the absolute value function, you need to make a piecewise defined function. We're not going to spend too much time on that. If we run into it, we run into it, and I'll address it then. But right now, this is a simple function. I can graph it. Remember, this still means the area underneath this function. So I will graph this, and this is the absolute value v shifted to the right 1. So there we go, and it looks like this, right? And like this. Oh, it is beautiful. And I'm taking the area from 1 to 3. Well, 1, that's 2, that's 3. How high is that? That's if I plug in 3 for my x value, what do I get? 3 minus 1 is 2. So this is a height of 2. Okay, so it's just the area of a triangle. A 2, base of 2, height of 2. So that area right there is what, 1/2 times the base times the height, and then it goes away. It's just 2. So plus 2. So this is 6. And that's what we have. It's pretty easy. One more video though. One more. That's how you do it. Fundamental theorem of calculus. It's so nice.